I think this question paper you did it right now is very good question paper. Let me consider the answers here. I hope you did it well. Anyway, what are the first question? First question says ammonium chloride crystallizes in BCC with a cell edge length 387 picometer. And you know BCC means if chloride ions are situated at the corner, ammonium ion should be in the body center, or you can think in the reverse way also. If ammonium ions are situated at the corner, chloride ion should be in the body center. Anyway, suppose you are thinking that chloride ions are in the corners and ammonium ion situated in the body center, and if you take a body diagonal, you can see that there is diameter of the ammonium ion and 2 chloride ion radius. So the body diagonal of a cube means what? A root 3. This a root 3 should be equal to the sum of 2 anionic radius and sum of 2 cationic radius. I hope you agree with me. Here is anionic radius, this one is cationic radius. Now all these things are given except the radius of ammonium ion. A is given as what? 387 picometer. 2 into radius of the anion is given 181 and radius of the ammonium ion is missing. You can do it. Okay. So on solving, I think you may get answer 154.1 picometer. You please do it. Now let me introduce the next question. Which of the following has least tendency to dimerize? Excellent question, you know. All of you know that NO2 has a tendency to dimerize. Please note that all the options selected here are odd electron species. Generally, all odd electron species has a tendency to dimerize. Isn't it? NO2 on cooling, you will get colorless N2O4. And ClO3, you have studied, it exists as Cl2O6. And no doubt MnCO5 times that exists as Mn2CO10 times, isn't it? That there will be manganese covalent linkage. You studied in metal carbonyl about this in detail. Now what about ClO2? You know ClO2 is also an odd electron species. Still it will not undergo dimerization because of the extensive delocalization of that electron that you have studied. But in this case, the remarkable point I would like to mention, even though it is not related to this question, is that MnCO5 times is expected to be very powerful oxidizing agent. How do you know that? Because it has a very strong tendency, even if it cannot exist as such, but it can exist by the gain of electron. How do you guess it? Because you know, in metal carbonyl, effective atomic number rule is always valid. You know, manganese possesses 25 electrons. By gaining of 5 CO, 5 into 2, total of 10 electron is gained. So as such, the total electron now become 35. Each ligand contribute 2 electrons, you know. But in order to attain the nearest noble gas, it requires one more electron. That is why that will readily become MnCO5 times negative. That's what I told you. It's a very powerful electron gaining agent. That means it is a very powerful oxidizing agent. Clear now? Anyway, our answer is ClO2. You know that it cannot undergo dimerization. It's a beautiful question. What about the next question? The ionization energy of helium plus is given the energy of the first stationary state of Li2 plus. All of you know that energy of monoelectronic species, ionization energy of monoelectronic species is 2.18 into 10 raised to minus 18 z square by n square, but you need not to bother about that result here because they give you the ionization energy of helium. You want to know only that ionization energy is directly proportional to z square. So ionization energy of helium plus divided by ionization energy of which one? Li2 plus is equal to 2 square divided by 3 square, which is given here. Ionization energy of helium plus is given to you. What is it? 19.6 into 10 raised to minus 18. So what you want to do? You want to multiply this with 9 and divide by 4. That is 19.6 into 10 raised to minus 18 into 9 divided by 4. You will get the answer. I expect this may be the correct answer. Please verify it. What about the next question? In question number 49, you want to name this complex. This is very familiar question. I think this is your textbook question. Potassium trioxalato aluminate 3. I need not to explain further. You know all these things. Potassium is +1 charged. Oxalate possesses -2. All these factors all of you know. So where is the correct answer given? Potassium trioxalato aluminate 3. Now what about the question number 50 or 5? Copper can be reduced from acidic copper sulfate solution by. You are very familiar with the activity series that you have studied. You know that lithium, potassium, sodium, actually you have studied 10th standard as an activity series. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, nickel, isn't it? Tin, lead, then comes hydrogen, copper, mercury, silver, gold, etc. You know this idea. Hydrogen said to possess standard electrode potential as 0. All these possess negative reduction potential and copper possess positive electrode potential. Based on the activity series, please don't forget that this is activity series. Based on the electrode potential series, there is small difference. That you have studied in 10th standard as lithium, po, so, ka, ma, al, zi, I, ni, ti, le, hi, ko, merci, plagos and that. But strictly based on the electrode potential, if you arrange, you can see lithium, potassium, calcium, sodium, so that will be like that. But it's not relevant here. Anyway, the metal silver is less active than copper, so it cannot displace copper. Iron is more active than copper, so no doubt it can displace copper. Carbon being a non-metal, lead, lead can also displace cupric ion from solution. But based on the data, iron is a much better that you have studied that if you put iron nail in copper sulfate solution, the nail become copper nail, copper get coated over the iron that you have studied. Anyway, you can select both, but better answer can be iron because iron possesses very strong tendency to get oxidized. Okay, let me go to question number 51. See here, this is also a wonderful question. You know very well what will happen when CH double bond CH2 get protonated. You will initially get a carbocation over here. So the carbocation so generated will be like this. No doubt all of you expecting a ring expansion here. So the ring expansion produce 4-membered ring so that the carbon attached with the oxygen now carry positive charge. So no more further discussion is needed. On deprotonation, you will get C as the correct answer. So that the first step is the addition of H plus across carbon-carbon double bond is important. Now let me go to question number 52. If all the electrolytes are removed from colloid by persistent dialysis, you have seen that by persistent dialysis, colloidal state become unstable and that will get coagulated. You know why? Generally, the stability of lyophobic colloids is attributed due to their charges. Because of the charge, it can exist as such, even though the colloidal particle hates the media. But if you remove all the charge by persistent electrolysis, what will happen? The particles get accumulated, they aggregate together and has a tendency to coagulate. So the colloids get coagulated is the correct answer. What about this one? For an SN2 reaction, the most effective nucleophile. It's a familiar question to all. You can see that the effective nucleophile, you know that all these are nucleophile and a very strong basis. But they have a tendency to get substituted and also it acts as a powerful eliminating agent. And If the group is bulkier, naturally you are expecting elimination rather than the substitution. So these are all bulkier and least hindered one is methoxide. So no doubt this is favorable for SN2 reaction. The substitution is favored here, whereas in other options, being bulky, they favor elimination reaction. Clear now? See, in this question, what do you want to find out? The solubility order. All of you know that if you consider the solubility, this is clearly wrong. We know barium sulfate possesses very low Ksp and its solubility is very small. All of you know that in the case of alkaline earth metal, the solubility trend of sulfate, nitrate, carbonate, chloride, bromide, and even iodide follows the reverse order. So this is clearly wrong. That cannot be the correct one. What about this one? Thermal stability. All of you know that beryllium carbon is thermally unstable. You know that beryllium carbonate should be kept under the atmosphere of carbon dioxide that you studied in detail, because that itself readily undergo, even without heating, beryllium carbonate undergo decomposition. All of this is so simple to guess, because if the cation possesses high polarizing power, that means this is being very small, it possesses very high polarizing power. In all that case, what will happen? That will readily polarize this electron towards it and readily undergo decomposition to produce beryllium oxide and carbon dioxide. Always like that. In any group, if you move down, the thermal stability of carbonate will increases, because the first species possess high polarizing power, so that will possess very strong tendency to get oxide. Clear now? So clearly this is wrong. What about this one? This is correct. All of you know that OCl, the electrode potential, if you analyze, this possesses very high value, higher value compared to what? The reduction potential of this one, and this is greater than the reduction potential of this one. So clearly this is a very powerful oxidizing agent. Sodium hypochlorite possesses greater oxidizing power. What about D option? This is also very important, but these are very familiar factors to you. You know that fluorine, chlorine, bromine, and iodine compare the bond energy. Cl2 greater than, Br2 greater than, F2 greater than I2. All of you know. You know that in fluorine, it being very small, the lone pair repulsion is much higher. Hence, the bond dissociation energy is very less. That is the reason why, fluorine becomes super halogen. Based on the electron affinity, chlorine possesses very high electron affinity, but fluorine being the most reactive nonmetal because of very low dissociation energy. Counting the dissociation energy and no doubt electron affinity, fluorine become very powerful nonmetal. Isn't that? Okay, let me go to the next question. So the correct answer here is C. What about question number 10? Which of the following molecule has highest dipole moment? You know that BF3 and carbon tetrachloride possess zero dipole moments, because BF3 is planar triangular. Each BF bond angle acts at an angle of 120 degree. All of you know that if two vectors acting at an angle 120 degree possess the resultant equal to one of them. So this BF bond possesses the dipole moment equal and opposite to the resultant of the other two, that make the dipole moment zero. Same way, carbon tetrachloride is also symmetric. The resultant dipole moment made zero there. These two are very familiar to you. You know that in the case of NH3, its dipole moment is much higher compared to that of NF3, even though NH bond dipole is less than NF bond dipole. If you compare the bond dipoles, NF bond dipole is much higher compared to NH dipole. But if you consider NH3 and ammonia possess higher dipole moment, all of you know. You know the reason. If you compare hydrogen and nitrogen, nitrogen is more electronegative. So the bond dipoles are directed towards nitrogen, whereas orbital lone pair always move away from central atom. So you can see that there is a converging effect. Bond dipoles and orbital lone pair dipoles acts in the same direction. What about fluorine and nitrogen? Fluorine being the most electronegative, the bond dipoles are acting towards the fluorine, whereas orbital lone pair directed away from it. So there is a diverging effect. Hence, NF3 possesses much less dipole moment than that of ammonia. So the correct answer here is ammonia. What about next question? Which of the following amines form N-nitroso derivative when treated with NaNO2 and HCl? You know NaNO2 and HCl in situ produce nitrous acid. That is, the question asked is the action with the nitrous acid. All of you know that nitrous acid is an excellent reagent like Hinsberg reagent to distinguish primary, secondary and tertiary amines. And what about methanamine? All of you know that in general the primary amines when treated with nitrous acid you will get alcohol with the liberation of nitrogen gas. But methanamine is strikingly important. Methanamine produce dimethyl ether and methyl nitrite also during that reaction. And anyway, you are not going to get N-nitroso here. And what about this compound? You know, aromatic tertiary amine that will give rise to para-nitroso compound. That is not expected here. Our answer clearly, see, all of you know that when secondary amine is treated with nitrous acid, you will get N-nitroso compound. N-nitroso derivatives is obtained here. So that is our answer. And you know very well that about Lieberman's nitroso reaction and all. So I need not to spend much time on it. What about this one? You know aniline. Aniline when treated with nitrous acid, you know it is diazotization. You are getting what? Diazonium salt, isn't it? Let me go to the next question. The reagent cannot be used to detect the presence of carbonate and bicarbonate in a mixture. It's an excellent question, isn't it? But all of you know that calcium carbonate is insoluble, whereas calcium bicarbonate is soluble. I am directly going to that answer because all of you know magnesium chloride. You know why? Magnesium 2 plus will convert the carbonate to bicarbonate also. Suppose the solution is already there is carbonate alone. By the addition of MgCl2, what will happen? Some quantity of carbonate itself transformed to bicarbonate in the same solution. So how can you distinguish the carbonate and bicarbonate? By the addition of magnesium chloride. The added Mg2 plus itself will convert some carbonate to bicarbonate. That all of you know. So the MgCl2 cannot be used to distinguish carbonate and bicarbonate in the solution. Now, what about this question? Change in optical rotation with the time of freshly prepared glucose is known as, all of you know the answer, mutarotation. It's a very familiar one. You know that if you prepare freshly prepared alpha D glucose, what will happen? Its optical rotation is about 111 degree. But if you prepare freshly prepared beta D glucose, pure beta D glucose, you know that its optical rotation is about 19.2 degree. But if you prepare alpha D glucose and kept for some time, what will happen? Its optical activity will decreases to plus 52.4 degree. And meanwhile, if you keep beta D glucose for some time, what will happen? Its optical rotation increases to 52.4 degree. You know the reason. If you keep alpha D glucose, it will forms open structure and again cyclic structure, open and cyclic. Ultimately, you know that in the equilibrium mixture, you will get 36% of alpha D glucose and 64% of beta D glucose. That is why 36 into 111 plus 64 into 19.2 divided by 100 will leads to 52.4. So the increasing the optical rotation from 111 degree to 52 point, I will repeat, decreasing the optical rotation from 111 degree to 52.4 degree and increasing the optical rotation from 19.2 to 52.4 is called mutarotation. Clear now? You are familiar with the idea of inversion of cane sugar. So that if you prepare cane sugar solution, initially it is found to dextrorotatory. But when the hydrolysis is completed, you will get one glucose and fructose. Glucose and fructose in the ratio 1:1. You know fructose is levorotatory and levorotating power of fructose is greater than that of the glucose. So the final solution become what? Levorotatory. So initially the sucrose solution was dextro and after the hydrolysis the solution become levorotatory. That is called inversion of cane sugar. Now let me go to the next question. What about this question? What will be the value of Ka2? Ka1 is given for a given concentration, that is C1 and C2 are the same. All of you know that Ka equal to C alpha square by 1 minus alpha, or you can approximate 1 minus alpha as 1. Ka equal to C alpha square, or Ka1 is C1 alpha 1 square, or you can directly write alpha 1 by alpha 2 is equal to root of Ka1 by Ka2. That all of you know. What is alpha 1 given here? Alpha 1 by alpha 2 is given as 1 by 2 root of Ka1. Ka1 is given as 2 into 10 raised to minus 4 and you want to find out Ka2. Squaring it become 1 by 4. So you can write 1 by 4 is equal to 2 into 10 to the power of minus 4 by Ka2. So Ka2 is 8 into 10 to the power of minus 4. You can select A as the correct answer. What about question number 60? 1 mole of an ideal gas initially at STP is heated at constant volume to twice the initial temperature. For the process, what is W and Q? You know that W should be 0. Why? They keep volume constant. No work is done by the gas. That is, as long as V is constant, delta V is 0. We know the magnitude of work is P external into delta V. Therefore, it is 0. So, work is 0. Work is 0 given in A and B. And clearly, Q cannot be 0. You can directly conclude the answer is A. But let me verify this answer. What do you want to find out? You want to find out QV. QV means what? Heat absorbed at constant volume. It's otherwise called delta U. QV equal to NCV delta T. What is N here? 1 mole. CV is given as 20. What is delta T? At STP means initial temperature is 273 Kelvin. Double of 273 is 546. 546 minus 273, that is 273. That will be the this much. This is obtained in terms of joule. If you convert it into kilojoule, you will get 5.46 kilojoule. Now let me go to the next question. Hydrogen and oxygen can be produced by the electrolysis of water. At what volume in liter? O2 and H2 are produced. You want to get it in liter. All of you know that during the electrolytic decomposition, you will get 2H2 and O2. What does it mean? This suggests that in order to get 1 mole O2, I am taking either O2 or hydrogen. Now let me take oxygen here. 4O2 minus become 2O2, or you can say O2. You can directly write in this way also. That is, if you consider 2O2 minus become O2, you are considering 4 electron transfer. That means, in order to obtain 1 mole oxygen, you require 4 Faraday. Along with, during the production of 1 mole oxygen, automatically 2 mole hydrogen is also produced. Am I right? So, 4 Faraday, 4 into 96,500 Coulomb can proportionally produce 2 plus 1, 3 mole. That means 3 into 22.4 liter gas at STP. Am I right? 2 mole hydrogen produced along with 1 mole oxygen. Total of 3 mole gases can be obtained by the expense of 4 Faraday. Now you know Q equal to I into T. What is I here? 30 ampere. What is the time? 193 minutes. 193 into 60 seconds. That is this much Coulomb, 30 into 193 into 60, that much Coulomb can directly proportional to what? That can produce X liter gases. You want to find out this value of X. You just divide and you will get it as what? 4 into 96,500 divided by 30 into 193 into 60 should be equal to 3 into 22.4 divided by X. So what can be the X? X equal to 3 into 22.4 into 30 into 193 into 60. You can solve it. I need not to spend the time over here. On solving, you can find out. I think the answer expected over here is C. You please verify the answer. Now let me go to the next question. Sodium carbonate react with SO2 in aqueous solution to give. It's a wonderful question. Sodium carbonate, you know, Na2CO3 when treated with sulfur dioxide, you know sulfur dioxide is more acidic than carbon dioxide. Naturally you are expecting NaHSO3 along with the liberation of carbon dioxide. That all of you expected. You want to add water over here. So if you want to balance, how will you do it? You can put 2 NaHSO3 and 2 SO2 over here. Now I hope it is balanced. Okay. Now sodium bisulfite so produced will not exist in solution, you know. You know why? Sodium bisulfite and sodium carbonate cannot coexist in the solution. Sodium carbonate is there. The sodium carbonate in the solution will readily react with the sodium bisulfite again. So you will get what? You will get sodium sulfite along with the liberation of carbon dioxide and water. How will you balance it? Let me put 2 here. So that let me put 2 Na2SO3. I think now it is balanced. You please verify it. So the final product should be Na2SO3. Please don't forget, initially you are getting sodium bisulfite. But we know that sodium bisulfite and Na2CO3 cannot coexist together. That will react with the Na2CO3 you take originally, and finally the solution become sodium sulfite. So the final answer can be sodium sulfite. The question can be made in this way also. Suppose the sodium carbonate is limited, you may even guess the answer as sodium bisulfite. Clear? Now let me go to the next question. Regarding the structure of cyanamide ion, pick out the wrong statement. All of you familiar with the calcium cyanamide etc. And in that case, how will you write it? You know the cyanamide structure. That means you can write in a better way in this way. Calcium cyanamide. Cyanamide ion is like this. What are the wrong statement? You want to identify the wrong statement. It has 1 carbon, no doubt. With a negative, it's wrong. There is 2 negative charge. So this statement is wrong. That may be our answer. What about the other options? There are 2 sigma bond, there are 2 pi bond. It has 2 negatively charged nitrogen atoms. All these are given. So the wrong idea here is A. Please note that this species is a linear one and it has 1 carbon but with a 2 negative charge. So option A given is wrong. A freshly prepared ferric hydroxide precipitate is peptized by adding FeCl3. Clearly you know that when ferric hydroxide is added with ferric ion, here excess of OH minus is not there. Instead ferric ion is higher. So naturally the ferric ion will go and adsorb over it, giving rise to positive charged colloidal particles. Now let me go to next one. Correct order of the boiling points. Fortunately, all the species given here are familiar compounds. Hydrogen peroxide you studied in detail. Its boiling point is at about 150 degrees Celsius, whereas the water possesses 100 degrees Celsius. And HF and ammonia. Fortunately, I selected correct option A. Because you know that boiling point of HF is no doubt it is greater than 0 degree, that is nearly about 19 degree or so. You please check it. But ammonia, it is about minus 33 degree, all of you know. So the correct option given A itself is correct. So then hydrogen peroxide has higher than that of water. HF is 19 degree approx, ammonia minus 33 degrees Celsius. So A can be selected as correct answer. Which of the following statement is wrong? All methyl ketones gives positive iodoform test. You know that the characteristic test, methyl ketones are highly characterized by iodoform test. We want to select the wrong statement. So that cannot be taken as wrong. Acetaldehyde is the only aldehyde. It's also an excellent statement. You know, in acetaldehyde, there is CH3CO group. This is the only one aldehyde. It can answer iodoform test. All secondary alcohol give positive iodoform test. You know that clearly option C is wrong. You know that alcohol can answer iodoform test only if that alcohol oxidized to produce methyl ketones. If that alcohol on oxidation gives methyl ketone, no doubt that can answer iodoform test. But if the alcohol is taken like 3-pentanol, there is no iodoform test formation. You know why? This is a secondary alcohol, but it cannot lead to the formation of methyl ketone during the oxidation. So this is clearly wrong. Any alcohol that can be oxidized to acetyl group gives a positive iodoform test. The alcohol which can answer iodoform test if it is oxidized to give CH3CO group. So that can be correct option. So the wrong option is C. What about the next question? Na2O4 on decomposition produces 2NO2. The observed molecular weight is 80. You want to find out the percentage dissociation of N2O4. You can simply do in this way also. N2O4 decomposes to produce 2NO2. And I just assume that if you take originally 1 mole N2O4 and after the decomposition N2O4 is 1 minus alpha. What about NO2 here? It should be 2 alpha. So then here you can even use what? You can even use the want-of factor that you have studied, even though want-of factor is applicable for what? Dilute solutions. I am using that idea here again. In general, you know, what is want-of factor? That is real molar mass, original molar mass, you know, 92. The molar mass after decomposition, that is given as 80, is equal to what? Particles after association or dissociation divided by particle originally added. Particle after dissociation or association is what? This undergo dissociation. After that, the number of particles become 1 plus alpha. So it should be equal to 1 plus alpha divided by particle added here, 1. So even if you forgot the formula that you studied in first unit, you can simply remember this identity also. The original molar mass by molar mass after dissociation should be equal to the total particle present divided by total particle added originally. We will always take 1 mole originally, isn't it? So you want to find out alpha here. 92 by 80 minus 1 will give you alpha, that is 12 by 80. Approximately it can be what? 0.15 I think. So the probable answer may be 15%. You please verify. I hope it is clear. Now, question number 68. You want to arrange based on the acidic strength. All of you know that here nitro compounds are given. Clearly, fourth one is the strongly acidic. You know, NO2 group possesses minus I effect and also minus R effect. But minus R effect cannot operate from the meta position. So counting minus I and minus R, the fourth should be strongly acidic. Fortunately, there is only one answer like that. 4-nitrophenol is strongly acidic. And don't forget that if you consider inductive effect alone, inductive effect will dominate from meta than that in para because inductive effect transmit through carbon chain. But meta-nitrophenol is much less acidic than para-nitrophenol because here the dominating factor like minus R cannot operate. So counting both, 4 then comes 3. All of you know that methyl being an electron pushing group that will reduce the acidic nature. So the correct answer is option D. What about the next question? Two liquids A and B, P0A and P0B are in the ratio 1:3. If the ratio of the number of moles of A and B are 1:3, the mole fraction of A in vapor phase. You want to find out mole fraction of A in vapor phase. We know that is generally denoted as Ya. According to Dalton's law, mole fraction in the gaseous form is equal to what? Mole fraction of any one of the component is equal to its partial pressure divided by total pressure. That all of you know. According to Raoult's law, Pa is nothing but P0A Chi A and P total is P0A Chi A plus P0B Chi B. So what is Ya that you want to find out is equal to P0A. The ratio is given. Let me directly put it as such because if you take that sum that will get cancelled, you know. So 1:3 I can take P0 as 1 here. If you take P0 as 1, you want to take P0B as 3. I am not taking 1x, 3x, etc. because you know that will get cancelled. So let me put directly like 1 here. So 1 into Chi A, and Chi A I can put it as what? Actually you know that Chi A is, if you take 1:3, that is 1/4, but I am taking 1 here because 4 get cancelled. So P0A Chi A divided by P0A Chi A plus P0B Chi B. P0B here is 3 and Chi B here is what? 3. So you please note that I am putting the ratio directly because the denominator term get cancelled. That's why I am not unnecessarily putting the denominator factor here. I hope it is clear. So 1/10 that will be equal to 0.1. So correct option can be taken as A. I hope it is clear. In the Born-Haber cycle for the formation of solid common salt, the largest contribution comes from, suppose you are considering the formation of 1 mole sodium chloride. Solid sodium combines with chlorine gas produce 1 mole sodium chloride crystal. This is called enthalpy formation of sodium chloride. If you consider this, what are the energy factors involved? First thing, you want to sublime it. On sublimation, you require enthalpy of sublimation here. And then you want to knock out that electron to generate Na plus ion. That means you want to supply ionization enthalpy here. Now come to this part. You want to give bond dissociation energy. Why I am taking half? I want only 1 chlorine atom here. So bond dissociation energy by 2 if supplied, you will get chlorine gas. Now you are giving an electron to it. Then electron gain enthalpy is involved and it becomes Cl minus. You may wonder that all these cases seems to be endothermic. This is highly endothermic. This also endothermic. So all this seems to be endothermic process here. This part is also endothermic. Only this part seems to release a small energy. Still, how will you justify the formation of rock salt? Even though in all this case energy is consumed much greater than the liberated energy. Still, you can explain the formation of NaCl based on what? Suppose you are considering the combination of Na plus gas and Cl minus gas leading to the formation of 1 mole sodium chloride. What will happen? You will get the lattice enthalpy get liberated. You please note that lattice enthalpy is defined as the energy needed to ionize 1 mole solid crystal into opposite charged gaseous ions. Actually, this one is lattice enthalpy, but during the formation of 1 mole solid crystal from opposite charged gaseous ion, its lattice energy get liberated. Actually, that will compensate all these things leading to the formation of sodium chloride. So, if you consider formation of sodium chloride, the largest contribution comes from its lattice energy. Clear now? Now, let me go to the next question. Among the following substituted silanes, the which one will give rise to cross-linked? Let me consider the first option. You know that this one is used to terminate the growing chain, trialkyl silicon chloride, that will be used for termination because 3 alkyl group is there, it cannot further grow. So that this part become hydrolyzed, and during polymerization this part become terminating. And this can never act as a monomer. And what about this? This is our answer. Here it is 3 chlorine atom. So on hydrolysis you will get 3 OH group. So it will give rise to branching. So branched chain or cross-linked silicons can be obtained by what? By using trichloroalkyl silicate. Clear? A linear silicons is obtained by this one. This can never act as a monomer. This is added in order to terminate the growing chain. It's also very important questions, you know. Even though these are simple questions, these questions are also very important. All the questions seems to be important in this unit. Malonic acid on dehydration with P4O10. Malonic acid, you know that propane dioic acid. If you take malonic acid, dehydration with P4O10, you want to remove water molecule. If you remove water molecule from both sides, what will result? You will get carbon suboxide. You will get carbon suboxide. In carbon suboxide, what is asked? What is the structure? You know, it possesses linear structure. Carbon suboxide possesses linear structure, that all of you know. What about question number 73? Mixing the two, the resulting mixture is simple one. What about the number of equivalents of HCl? If you consider number of milli equivalents, you know, volume in milliliter into normality will give you number of milli equivalent. 4 milli equivalent acid is there. Let me check how many milli equivalents of alkali is there. 60 into 1 by 2, 20 milli equivalent. There is 3 milli equivalent is there. So 4 milli equivalent acid and 3 milli equivalent of base. So clearly the resulting solution is acidic. What about question number 74? You want to create a double bond over here. The reagent, the most appropriate reagent is, I am sure that you will not select first option, because even though it is a very good dehydrating agent, but the dehydration proceeds through the formation of carbocation. The OH get first protonated and liberation will generate a carbocation that will definitely undergo ring expansion. So the ring expansion should not be here. So we should not opt option A. All of you know that this is an excellent one. So alumina, if cannot undergo rearrangement, there is no formation of carbocation here. So B can be selected as the answer. Why don't you select C here? You know, C is used if you want to prepare a double bond over in this side, that is terminal part. In this here, you will select thoria. So that you are very familiar with its action. But the alumina is used here in order to get more stable product. The more alkene having greater hyperconjugation is preferred if you are using hot alumina. Clear now? That is why I am omitting thoria. I know if sulfuric acid is added, the carbocation generation will be there. Now, what about this one? Increasing basic property. All of you know that this is amphoteric, and down the group basic nature will increases. So titanium, zirconium, hafnium belongs to the same group. Increasingly, the basic nature will increases down the group. So this is amphoteric. Please note that point. Titanium dioxide can react even with acid and base, but these two are distinctly basic. So I think the correct answer given is A. Titanium possesses the lowest. Fortunately, there is only one answer, and all of you know that titanium dioxide possesses amphoteric nature. Question number 76. In a solid AB having NaCl structure, A atoms occupy the corners and face centers of the cubic unit cell. If all the face centers atoms along one of the axes, that is, you are removing all the particles along the face center axis. Suppose an axis passing through this face center, that should come out through this face center also. These two particles are missed. Now, where is this A situated? A situated at the corners. So, contribution of corner 1 by 8, and there are 8 such corners. And again in face centers, you know, only 4 face centers are occupied. Out of the 6 face centers, 2 face center particles are missed. And so A can be total of 3. Am I right? A can be 3. What about B? There is no missing for B. B particles are present. Corners, that is, no, B particles are present in edge centers and in body center. B particles being in edge centers, that is 1 by 4 into 12 edges along with one body center particle. So total of 4 particles for B. So it can be A3, B4. Now let me go to question number 77. A very simple question. Intra-ester formation. I need not to explain. So simple. You know that during ester formation, hydrogen from alcoholic part and OH from acid is removed, and you will get a cyclic ester here. But it is easy to identify here, isn't it? Among the option, the oxygen attached to this carbon, the same carbon contain methyl group. Oxygen attached to this carbon, that carbon contain methyl group. So the correct option can be option D. A compound was found to contain nitrogen 28 gram. Nitrogen and oxygen is there. It's 28 and the other one is 80. It is very simple to identify its empirical formula. We will divide by its own atomic mass. Isn't it? You will get N2O5. Correct option is C. In this question, in an isothermal process at 300 Kelvin, 1 mole of an ideal gas expands from pressure 100 atm against an external pressure of 50 atm. You want to find out total entropy change. You want to find out delta S total. Delta S total, no doubt, is delta S system plus delta S surrounding. What about delta S system? Delta, it undergo isothermal expansion. How do you know that? From 100 atm, the pressure become 50 atm, pressure get halved. Naturally, volume get doubled. So, during that isothermal expansion, delta S system, all of you know, that will be 2.303 nR log V2 by V1, or you can say P1 by P2. Plus, no doubt there is delta S surrounding. Now, 2.303 into how many moles here? 1 mole gas is taken. Let me put R as 2. Why? They need to obtain in calorie. The value of R in calorie is 2. Log P1 by P2, 100 by 50, that is log 2. Plus, this on log 2 is 0.3010. You can take it as 0.6. So, that will be about 2.303 into 0.6, around what? It can be about 1.39 approx, plus delta S surrounding. Now you want to find out delta S surrounding. How will you find out delta S surrounding here? Naturally, what will happen? During this isothermal expansion, energy is needed because the entire energy should be taken from outside. How do you know that? The temperature of the system remains same. It is isothermal. Meanwhile, it performs the work. The entire energy for doing the work should be taken from outside. So the work done by the system is the same as energy lost by the surrounding. I hope it is clear. So energy lost by the surrounding, you know that delta S is equal to Q by T. We want to find out energy lost by the surrounding. How do you find out? We want to find out the work done during this process. What is work done? Work done equal to pressure external into change in volume. Pressure external is 50 atm here. 50 atm into change in volume V2 minus V1. How will you find out it? What is final volume here? Final volume you want to find out. We know PV is equal to nRT. So V equal to nRT by P. What is N? 1 mole. R into T. T is 300 divided by, what about final pressure? 50. So this is what? V2. This stands for V2 minus V1. What about V1? 1 into R into 300 divided by 100. I hope you can see. You know what is it? It stands for 300 there. So let me write it here. 50 into, what is it? You can take R outside, 300 outside. 300 R is taken outside. And what remains? 1 by 50 minus 1 by 100. That is 2 minus 1 by 100. That is 1 by 100. Do you agree with me? That is, here it become, if you take 100 as LCM, this become 2. 2 minus 1 by 100. That is 1 by 100 here. Now, this is the magnitude of the work done by it. You know, work is actually minus P external into change in volume. Okay, you can see here, if you put R as 2 calorie, 2 into 50, that will be what? That will be giving rise to, what about here? 2 into 50 here, 100. So that will be equal to 100 into 3, that is around 300. See, you know that we are finding out what? We are finding out Q. So that, what is Q here? The Q here you got it as 150 R. Do you agree with me? You can take R as what? R as 2 calorie. So 300 calorie is the work done by the system. To do this work, energy is taken from the surrounding. So Q here is what? Q here is 300. But 300 calories absorbed by the system. That means 300 calories lost by the surrounding. So for the surrounding, Q is minus 300. So 1.39 plus, what is Q? I told you it is minus 300 calorie. You please note that point. 300 calorie work is done by the system. For doing that work, entire energy taken from the surrounding. So the energy lost by the surrounding is minus 300 by temperature. What about temperature here? 300. So 1.39 minus 1, that is 0.39 will be the answer. So the correct option can be option B. I hope it is clear. Now let me go to the next question. What about this question? Hydrogenation of the above compound in the presence of sodium in liquid ammonia. Birch reduction. You know that this is addition of hydrogen involves in transposition and deposition. Isn't it? So you are getting, please note that the given compound as such possesses a stereo center. Now this compound is optically active even before hydrogenation. If you hydrogenate it, the 2 hydrogen adds, you know, sodium in liquid ammonia cannot hydrogenate the double bond. It will convert the triple bond to double bond. While converting the triple bond to double bond, the hydrogen should be added in transposition. The 2 hydrogen should be added in this way. So that you can see that the stereo center even now remains as such. The stereo center will be the same. Why? The hydrogen added will be in the transposition. This is already in cis position. This is trans. This group is not the same as this group. Even though they possess same number of atoms and all, these are cis and trans isomers and these two are different. So even now there is this stereo center. I hope it is clear. But please don't forget that instead of sodium in liquid ammonia, if you use hydrogenation in presence of Lindlas catalyst, this triple bond becomes cis alkene and these two group become identical. So its stereo center is lost and it become optically inactive. But here you are using sodium in liquid ammonia, so that this is already cis and now this become trans. Even now there is the same stereo center. So this compound can be optically active. Now what about this question? It's a wonderful question. You want to find out A and B. You know that in this case the formation of A is by the action of 4 molar NaOH. You are taking OH minus ion concentration in large amount. Clearly you know that the SN1 and SN2 mechanism, if you consider the rate of the reaction K into concentration of alkyl halide into nucleophile concentration, if you consider, and in the case of SN1 you can write it in this way. Now you know that in this case OH minus concentration is much higher, so that this part is very high and automatically this concentration increases, means A is mainly due to SN2 pathway. Why? OH minus concentration is considerable, so that you can have SN2 way. So the formation of A is through SN2. So naturally you are expecting what? OH minus will come and attack from backside of the bromine and you will get an inverted product. SN2 will result in inversion. Okay, now coming to formation of B. During the formation of B, OH minus concentration is very small. So most of the product obtained will be through SN1 pathway, where OH minus concentration is not inconsiderable. I hope you are following. During the formation of A, since OH minus concentration is higher, you can put OH minus concentration here, so that the reaction mainly proceeds through SN2. I told you. Since OH minus concentration in this part is much less, most of the reaction will be through SN1 pathway. So here again comes another remarkable point. You cannot expect racemization. Why? You can see here NGP. I told you here I am not expecting racemization because you know neighboring group interaction. This O minus group possesses very strong attraction towards this positive center, so that will be interacted over this side, isn't it? The moment bromide leaves, O minus is interacting over there. So the OH minus can attack only through the side by which bromide is lost. I hope you are following. മനസ്സിലാവുന്നുണ്ടോ? അതായത് ഇവിടെ ബ്രോമൈഡ് അയോൺ ഇരിക്കുമ്പോഴേ ബ്രോമൈഡ് അയോൺ ലീവ് ചെയ്ത് റെസിമൈസേഷൻ ഞാൻ എക്സ്പെക്ട് ചെയ്യുന്നില്ല. കാരണം നൈബറിംഗ് ഗ്രൂപ്പ് ഇൻട്രാക്ഷൻ. ഈ ബ്രോമൈഡ് ലീവ് ചെയ്യുന്ന സമയത്ത് O മൈനസ് ഇങ്ങനെ പിടിച്ച് നിൽക്കുകയാണ്. അപ്പോൾ ബ്രോമൈഡ് പോയ വഴി കൂടെ മാത്രമേ ആർക്ക് അറ്റാക്ക് ചെയ്യാനാവുള്ളൂ? OH മൈനസിന് അറ്റാക്ക് ചെയ്യാൻ പറ്റുള്ളൂ. അപ്പം മെജോറിറ്റിയിലും ഇവിടെ റീടെൻഷൻ തന്നെ കാണിക്കും. ക്ലിയർ നാവും. ഇതിവിടെ OH മൈനസ് കോൺസെൻട്രേഷൻ കൂടുതലാവുമ്പോൾ മെക്കാനിസം SN2 ആകും. അപ്പം നമുക്ക് ഇൻവേർഷൻ എക്സ്പെക്ട് ചെയ്യാം. എന്നാൽ ഇവിടെ OH മൈനസ് കോൺസെൻട്രേഷൻ കുറവായതുകൊണ്ട് the reaction pathway is expected to be SN1. SN1 എന്ന് കേൾക്കുമ്പോൾ നമുക്ക് തോന്നുന്നത് റെസിമൈസേഷൻ ആണ്. പക്ഷേ ബ്രോമൈഡ് ലീവ് ചെയ്ത മൊമെന്റ് തന്നെ NGP, നൈബറിംഗ് ഗ്രൂപ്പ് ഇന്ററാക്ഷൻ, ഇറ്റ്സ് വെരി ഇമ്പോർട്ടൻറ്റ് ദാറ്റ് യു നോ വെരി വെൽ. ഈ O മൈനസ് അതിൻ്റെ പിറകിലൂടെ പിടിച്ചു കഴിഞ്ഞിട്ടുണ്ടാവും. അപ്പോൾ പിന്നെ ബ്രോമൈഡ് ലീവ് ചെയ്തു. പിന്നെ വരുന്ന OH മൈനസിന് ബ്രോമൈഡ് ലീവ് ചെയ്ത അതേ വഴിയിലൂടെ മാത്രമേ വരാൻ പറ്റുള്ളൂ. അപ്പോൾ യു ക്യാൻ എക്സ്പെക്ട് the retention products. So what is the possible answer here? A and P are superimposable is wrong. The configuration of A is R and B is S. Let me check it. What about configuration of A? Bromide leave and OH minus enter. You know, if you put the priority as such, what about the priority? Higher priority goes to bromine, given as number 1. The second priority goes here, and third priority for CH3, lowest priority for hydrogen. So I am viewing the molecule in such a way that fourth priority is far away from it. So let me visualize the molecule in this way. So I can see bromine, I am viewing from bottom, so bromine project out, so outward, bromine to this carbon, from bromine 1, this carbon 2 and methyl. So 1, 2, 3, if you consider, you can see that I am viewing from bottom, you know, 1, 2, 3, it moves in clockwise direction. So originally this is R. What about A? That will be an inverted product. Do you agree with me? So A should be what? A should be S configuration. They say the configuration of A is R. So that cannot be taken. Now A and B are diastereomer. I told you earlier that what about A and B? A is obtained by inversion product and B is obtained by retention. So the correct answer goes to option D. I hope it is clear. Let me introduce question number 82. What about question number 82 here? Equivalent mass of the reaction. Here you know that NO2 group is attached over here. See, if you consider this CN bond, electron cloud attracted towards nitrogen, this bond contribute -1 for oxygen. These two bonds are attracted towards oxygen, giving nitrogen +2. We know that a coordinate bond produce +2 for the donor atom and -2 for acceptor. So the total oxidation state for the nitrogen here is +3. It is converted to aniline, and in this case you can see that from carbon to nitrogen, the bond is attracted towards nitrogen, contributing -1 for nitrogen. These two bonds is attracted towards nitrogen, giving -1 each. So the total oxidation state of this nitrogen is -3. So what is the change in the oxidation state? +3 to -3, the total change is 6. So the equivalent weight is molecular mass by 6. See this question. Which of the following statement regarding copper salts is not true? Copper 1 disproportionate. This is your textbook sentence. You know that in aqueous solution, Cu plus disproportionate to copper metal and cupric ion. Copper 1 can be stabilized by, this is also very famous, and Cu plus can be stabilized in presence of Cn minus, I minus, etc. What about C? Copper 2 oxide is red powder. You know that this is clearly wrong. So this statement is wrong. What you want to select is the wrong statement. So this is our answer. So our answer is C. You know, copper 2 oxide is black in color, that you have studied in 10th standard. In copper cooking utensils, bottom of the copper vessels become black due to the formation of copper oxide, you know. What about this? This is a familiar sentence in the NCERT textbook. Which unit? In the unit of hydrogen. Let me go to the next question. Antiseptic chloroxylenol. Chloroxylenol. You know that xylene in meta position, this is xylenol and this is chloroxylenol. What about this name? We can put the carbon number 1 here. 1, 2, 3, 4, 5 and 4 chloro and 3,5-dimethyl phenol. Am I right? So the correct option can be 4 chloro 3,5-dimethyl phenol. What about next question? Choose the incorrect statement in the following. Friedel-Crafts reaction between benzene and acetic anhydride in presence of anhydrous AlCl3 yield acetophenone and not polysubstituted product. No doubt, once acylation occur, what will happen? That will be a deactivating group, because directly attached atom contain more electronegative atom pi bonded to it. So naturally there is a very strong deactivation power. So after one acylation, All of you know that if benzene ring is attached with any group having minus R effect, there is no Friedel-Crafts reaction. So this cannot undergo Friedel-Crafts reaction, so there is no poly substitution. Acetophenone formed poisons the catalyst, preventing. No, acetophenone will not poisons the catalyst, but instead you can say in a better way, the ring get deactivated. That is the major reason why there is no further Friedel-Crafts reaction. During Friedel-Crafts alkylation reaction, rearrangement of carbocation take place. No doubt, carbocation will rearrange. Carbocation is poor electrophile than acylium ion. What you want to select is an incorrect statement. So, the incorrect statement is what? Friedel-Crafts reaction, this is also correct. What is incorrect statement I told you? Acetophenone formed poisons the catalyst is not correct. Instead, the acyl group entered will deactivate the ring. What are the other options? First one is correct. There is no poly substitution. The statement is correct. What about C statement? The carbocation is generated. Definitely it will undergo rearrangement. What about D statement? Carbocation and acylium, if you consider, carbocation and acylium is considered, clearly acylium is powerful what? Electrophile. Then what? Then alkyl carbocation. Clear now? So the wrong statement here is B. That should be our answer. I hope it is clear. Now let me introduce the next question. Identify the correct statement about the reaction. It is given as ester. This is a very familiar reaction to you. When ester is heated, there will be elimination of carboxylic acid. So that we are taking hydrogen from the beta carbon and removing a carboxylic acid molecule. And please note that this elimination is syn elimination. That is, we are eliminating from the same side. The elimination will occur from the same side. So, syn elimination will occur. Hydrogen and the carboxylate species and remove from the same side. So, we want to eliminate syn elimination. You know that CH bond energy is weaker than CD. So, let me write this in syn position. So, I am writing the same species in this way, OCOCH3 H PH. You know, in Fischer projection, you can rotate this either in clockwise or anti-clockwise direction. If you take H here and the deuterium will go here and the phenyl group will be here. Now, let me write it in this way. Now, you can write in a better way like this. Now, you can see these are in syn position. You can eliminate the two. You can eliminate carboxylic acid from here, resulting what? Resulting the species like H, phenyl group, and here phenyl group, deuterium. You are getting phenyl group in trans configuration. The elimination in syn elimination and the final product is a transalkene. So, the correct answer can be answer C. Do you agree with me? You please don't forget that when an ester is heated, that undergo elimination. The elimination is syn elimination, that carboxylate part will take the hydrogen lying on the same side. Clear? So, the resulting product, if you draw, you can see it will be a transalkene. So, the correct option can be C. What about question number 87? Lucas test is used to make distinction between primaries. No doubt, ROH behaves as a base. You cannot deny that statement because the lone pair is here, and what happens? The ZnCl2 act as a Lewis acid catalyst, that all of you know. So, ROH can behave as a base and then it will get protonated in that way also, it acts as a base. Greater the value of pKa of alcohol, greater the reactivity with concentrated HCl. What do you mean by greater the value of pKa? Greater the pKa means what? Less acidic. Lesser acidic means what? Its conjugate base is, it possesses greater basic property. So that can also be correct. So what about C? Both the above, so we can take C as the correct answer. I hope it is clear. Let me go to the next question, simple one. With that all of you know that ROH, initially the lone pair get protonated by H+. What about question number 88? A colorless fuming liquid A can be prepared by passing SO2 over phosphorus pentachloride. You know that when SO2 is treated with phosphorus pentachloride, you will get what? You will get thionyl chloride, SOCl2. Then the liquid can be hydrolyzed to give phosphorus acid, no doubt. During hydrolysis, the oxidation state will not change. The oxidation state of the sulfur here is +4. So during hydrolysis, you will get sulfurous acid. There also the oxidation state is +4. So clearly the correct answer can be thionyl chloride. Thionyl chloride on hydrolysis gives sulfurous acid, whereas sulfuryl chloride if you take, here the oxidation state is +6, that on hydrolysis may leads to sulfuric acid. Now let me go to question number 89. In Lesinus test, a blue color is a familiar question. Ferric ferrocyanide, that is called Prussian blue, isn't it? Ferric ferrocyanide, that is called what? Prussian blue. The total charge here should be -4. So if you interchange Fe4, FeCN6 thrice, that will be the answer. So this will be Prussian blue. What about the last question here? Dipole moment of lithium hydride is given as 1.964 into 10 raised to -29 Coulomb meter. What do you want to find out? The percentage of ionic character. You know that dipole moment is equal to magnitude of charge into distance. What will be the magnitude of charge developed here? You want to find out. What is the dipole moment observed? 1.964 into 10 raised to -29. It is in SI unit. Charge we want to find out. What is the distance here? 1.596 into 10 raised to -10 meter. So what is the charge developed here? The charge developed here is equal to 1.964 into 10 raised to -29 divided by 1.596 into 10 raised to -10 Coulomb. What will be the relative electronic charge? That is charge polarized to the electronic charge. You can get divided by E. What you want to find out is percentage ionic character. That is charge really produced divided by electronic charge into 100. So Q is this. What is Q? 1.964 into 10 raised to -29 divided by electronic charge is 1.6 into 10 raised to -19 Coulomb. Already there is 1.596 into 10 raised to -10 into 100. This is need to be determined. You can please calculate it. You can see that on solving this you may get the answer as C. So correct option can be C. I think this is an appropriate paper that you did it well, I think. Thank you.